Okay, boys, we're going to look at the equation of the line of best fits. Now, for any straight line, which is non-vertical, we can use the formula y equals mx plus b to find the equation of that line. So let's look at our example. Ball is rolled down a ramp and its velocity is measured over time. So here we go at t equals 1 second. Velocity is 0.7 meters per second. At t equals 2 seconds, velocity is 1.5 meters per second. Now, scatter plot is drawn below, and the line of best fit is drawn on there as well. Find the equation of the line and hence determine the velocity after 10 seconds. Okay, now, step one, let's just go down to that. We're going to find 2 points on the line to find the slope. In step two, we're going to use the point gradient formula to find the equation of the line. So let's go back to the line here. Now, the temptation will be to try and find the coordinates of one of these points, which is okay, but we've got to try and use points which actually lie on the line of best fit itself. So we don't have to use the data from the table, all right, because we're trying to find the equation of the line that's been drawn. So let's have a look at this one. It looks like it goes through here at 2, 2. So 2, comma 2 looks like one of the points, and this point here looks pretty good. Looks like it goes through this one as well. Let's use 4, comma 6. So we've got to stick to points that actually lie on the line. So I wouldn't be using this one or this one because it doesn't lie on the line. So 2, 2 and 4, 6. So let's use our formula y2 minus y1 over x2 minus x1 to get our slope. Okay, so what have we got? 6 minus 2, y2 minus y1 over x2 minus x1, 4 minus 2. Okay, so it's going to give you 4 divided by 2, which equals 2. Okay, so our slope is 2. And the next step is to use the point gradient formula. So we're going to go y minus y1. So let's just choose 2, 2 is our point. So y minus 2 is equal to, our slope is 2, x minus x1, x1 in this case is 2. Okay, so I'm just using this point here for my x1 and y1. Okay, so we can expand the brackets. Y minus 2, so you've got a 2x minus 4, and then y, so you've got a 2x minus 4 plus 2 is minus 2. Okay, so there's my equation. Now don't forget we've got velocity and time here, so we should actually change our variables now to v equals 2t minus 2. So that's the final equation that we're looking at. Okay, so now we can look at the velocity after 10 seconds. So I'm just going to sub in t equals 10. So 2 times 10 minus 2. That's going to be 18 meters per second. Done. Okay, that's all good. Now we've got to explain the meaning of the y-intercept and the slope of the line. So the y-intercept would be -2, wouldn't it? So, and the y-intercept corresponds to when t equals 0. So if I look at this part here, so t equals 0, and that means v will equal -2. So if we were to explain what that means, what the y-intercept means, so this is my y-intercept here, -2. The y-intercept is the initial velocity. Okay, so I'm going to write that down there. Y-intercept is the initial velocity. So part of the skill in these questions is being able to take your equation and interpret the slope and the y-intercept in the practical context of the question. So y-intercept is initial velocity in this case. Now, what about the slope of the line? Now, we know that the slope is 2. Okay, now the slope of the line. Okay, let's write that down here. The slope of the line. Well, the slope of the line, right? So, a couple of ways that we can think about that. We can say, well, it's really going to be dv dt. Okay. So, and if I differentiated that, obviously I would get 2. Now, it's the rate of change in it. Slope is a rate of change. Now we know dv dt is acceleration, so I'm going to write down acceleration equals 2 meters per second squared. So in this case, the slope of the line is the acceleration. But if it wasn't velocity, it was something else, you wouldn't need to write the calculus down. You could just write down m is equal to, and we calculated it was 2 meters per second, rise over run, 2 over 1, over 1 second. Okay. So it's telling you the rate of change of velocity every 1 second. So the velocity is increasing by a rate of 2 meters per second every second. So that's another way of explaining it. So whenever you're asked to explain the slope, you've got to interpret slope as a rate of change. And the slope will tell you how many units on the vertical axis are changing per 1 unit of the quantity on the horizontal axis. Okay. All right. Now let's have a look at something called Pearson's correlation coefficient. We've looked at correlation using certain terms like strong, moderate, and weak. So the correlation measures how well 2 variables are related if there seems to be a linear relationship between them. And we've used strong, moderate, weak, or no correlation, for example. Now, these are general terms. We want to associate some sort of mathematical number to those. So we use a measurement called Pearson's correlation coefficient. And the letter we use to represent Pearson's correlation coefficient is R. R is the correlation coefficient there for Pearson's correlation coefficient. So now that R value will tell us how closely related the variables are. So the values for R go between -1 and 1. Now, if you get a correlation coefficient of +1, so that's at the far end of the scale, then we say it's a perfect positive correlation. If you get a Pearson's correlation coefficient R equals -1, that means it's a perfect negative correlation. And if you get R equals 0, that means there's no correlation. So between R equals 0 and up to and including R equals 1, there's some sort of positive correlation there. So R is bigger than 0 in this region here, bigger than 0 and obviously less than 1. And here R is negative, so it's less than 0. Less than 0, but not greater than, doesn't go past the -1 there. Okay. Now, what are some things we can say? Well, the line of best fit has a positive gradient when the correlation coefficient is positive. So all of these scatter plots here will have a R value which is positive. So that means R value which is less than or equal to 1 but bigger than 0. All right, and if you were to draw the line of best fit there, obviously it would have a positive slope. Okay, so drawing the line of best fit there, that would have a positive slope. But just be aware, you don't think that the slope is equal to the correlation coefficient because it's not, but they are the same sign. Now, the line of best fit has a negative gradient when the correlation coefficient is negative. So all these scatter plots here have a negative correlation coefficient. And that means our line of best fit will also have a negative gradient. So if you draw some sort of line of best fit in there, obviously that is going down from left to right. Okay, so now we're going to match each scatter plot below with its correct correlation coefficient. So here are your choices. You've got 0.5, 1, -1, -0.4, and 0. So let's go for the easy one first. I'm going to take a guess that there's no correlation here for B. So I'm going to put R equals 0 for that one. Okay, so R equals 0. This looks pretty perfectly positive to me. R equals 1. And as I go down, I'm going to choose R equals -1. This is a perfect negative correlation, and that leaves two others. I've got a negative and a positive one, so this is going to be R equals -0.4, and this one will be R equals 0.5. So what you can tell is that the correlation coefficient tells you the tendency for the data to lie on a straight line. So when R is 1 or -1, then all the data for the bivariate data lies on a straight line perfectly. And as R gets closer and closer to 0, right, as it gets closer and closer to 0, so if we go back to our scale, as we get closer to 0, the points become more scattered and don't really follow any pattern. So as we get closer to 1 or -1, you'll find that the points start lining up more on a straight line. So the correlation coefficient really tells you how closely the points lie in regard to the straight line. Okay, now there is a calculation we can do on our scientific calculators to calculate Pearson's correlation coefficient. So here's an example. We've got a group of students who surveyed for the number of hours that they studied and their results in a maths exam. Find the correlation coefficients by variate data. So here it is. We've got number of hours studied in the top row, exam results in the bottom row. And here are the instructions, the calculator instructions. And if you do it right, you should get 0.738. So let's have a look. Got my little calculator here. Move that to the side. Now we're going to go mode and then 2 to put it in stat mode. Now up here you've got one variable and also you've got a plus bx. Now a plus bx, you've got to think of that as the equation of the line of best fit, and because we want the correlation coefficient, we're going to choose that. So choose 2. Now we've got two columns to put the bivariate data in there. So let's just let's scroll up a little bit so I can see the data. So I'm going to put that data in there. So we've got, we'll do the first row. So I'm just going to enter the first row, 6, and then 5, then 12, then 8, then 15, 9, and then 14. But there is a bit of a danger if you're entering just one row at a time, and that is you might skip a number. So just be careful. I'm going to use my little pad there to go back up to the top. I'll put in the second row. So I've got 71 equals 46 equals 74 equals 67 equals 76 equals 77 equals, then 83 equals. Okay, so I've done all that. So I've done the first part, I've done the second part. Now, this is important. You've actually got to press the all clear button next. So this button here, I'm going to press the all clear button. So let's do that, all clear. Then it tells me to go shift and then 1. The reason it says 1 is because there's a little stat feature there, shift 1. and then I'm going to choose 5. Now, why 5? REG, what does that stand for? It stands for regression. Now, regression is the name of the line of best fit. It's a regression line. So we're looking at for the tendency for the points to regress to the line of best fit. So REG stands for regression. So we're going to press 5, and we want the R values. So that's 3 there. So press 3, and then we're going to press equals, and we got 0.738, which is the correct value. So that's our lesson for today.